So let's see what happens when we have only one categorical variable and we just want to see what it is about. Throughout this video, we're going to use this data set about listings in Airbnb Berlin. So we have different information about a place that you can stay in, like, for example, somewhere over here, we have the neighborhood, the name of the place, the name of the host, what is the room type, price, etc., etc. So we have different information about it. And so what kind of things can we do with one categorical variable? Well, first of all, we're going to talk about statistical properties. If we're interested in the central tendency for the categorical variable, this means what is the most typical class or level or category in the variable. So for example, in the room type, we have entire homes or apartments, private rooms, and shared rooms. And perhaps we're interested in knowing which one is the most frequent. This is what we call the mode. And it's just that, which is the level or the category or the class that is the most often appearing in our data. We might also be interested in the dispersion. So, okay, we know in our data, the most often appearing is the entire homes or apartments. What about the others? Does it correspond to maybe 90% of the data, 95, only 60%? So we have two options here typically. The first of them is the variation ratio, which tells us what is the fraction of cases different from the mode. So if mathematically speaking, it's just 1 minus the fraction of occurrences for the mode. And so if in the mode, in this case, we have a little shy over 3,000 observations, and in total we have 5,000, then we know that 43% of the observations are different from the mode. And then we have something else called the entropy, which is measuring something like the amount of disorder in the data. So mathematically speaking, it looks something like this. I'm not going to go into details of the formula, but it's just giving us, again, another number telling us so how much variation we have. In our case, what we have is that 57% of the observations are entire homes, 42 at private rooms, and only 1% is shared room. If we run these numbers, then we have the entropy equals 1.05. And then as we vary these proportions, then the entropy is going to vary accordingly. Let's just take a look at the example. So in the case of the one categorical variable, what we are very often interested in is this, a contingency table. So essentially, this is telling us how many observations we have for each of the categories or each of the classes. So in the case of the room type, what we have here is 2,800 entire homes, 2,100 private rooms, and 48 shared rooms. So essentially, just describing the numbers. And very often, what we're going to be interested in is actually the proportions or the shares. So out of the total, what percentage corresponds to entire homes or what percentage corresponds to shared rooms, for example. And so as we saw earlier, something like 57% are homes and only 1% are shared rooms. And typically, this is what we are interested in because it's more informative, because we all know how to interpret percentages, but given an arbitrary number of observations here, it might be a little bit difficult. So we can also visualize it, and it looks something like this. This is a bar plot, and essentially what we have is in the x-axis, all the different categories of the variable, our three room types in this case. And then along the vertical axis, what we have is the number of observations, the count. And so again, in this case, we have almost 3,000 entire homes, apartments. Then we have around 2,000 private rooms and about 50 shared rooms. So what we see here visually very clearly is that most of the data is about entire homes or private rooms. There's virtually no shared room in the data. Now, with only three categories, it's easy to look at a table, but if we have more and more and more categories, then normally it's a lot better to just make some visualization like this. And of course, I guess you have heard about the pie charts. My recommendation is don't use them unless you have a very specific reason to do so. And here in this street, we have a very good reason for why we shouldn't use pie charts. And it's basically 3 data sets that, according to the pie chart, are kind of the same, right? It's almost impossible to see the difference. But it turns out that if you make a bar plot, like in here, you see that they correspond to 3 very different patterns on the data, which is something that just by looking at the pie charts, we would have missed. So again, recommendation is don't use them unless you have a very clear reason why you want to use them. Such as, for example, in this case, if you want to show that those 2 categories are already accounting for about 50% of the data. And in the general case, we can just provide the numbers, the variation ratio and the entropy. So let me show you here one example. We have on the left neighborhood groups, a different distribution for neighborhood groups in the data. So we have along the y-axis, in this case, we have the different neighborhoods. And along the x-axis, we have the count. So it's essentially a bar plot that has been flipped over. And what we see is that most of the listings, in this case, are in the neighborhood of Frederick Shane. And so the variation ratio in this case is 59. That means around 60% of the data are different from the mode. So all these around here are 60% of the observations. And in this case, the entropy is almost 3. So that's it. That's as much disorder we have in the data. Now, if we look at the one on the right, we see that, yeah, we have so many observations of Fredrickson again, but there is a second one that also accounts for a lot of the data in this other neighborhood. In this case, the variation ratio is just the same. 60% of the data are different from the mean. But then in all those observations different from the mean, still there are some of them that are more likely than the others, like this one over here. And so this is something that the variation ratio would completely miss because it's just taking a look at everything different from the mode. But in this case, the entropy is lower. And so this is a case in which we would have a reason to use the entropy and not the variation ratio because it would miss patterns in the data like this. But again, everything depends on your specific case, of course. Normally just provide the visualization and it's going to be a lot better. If you have to provide a numerical quantity, some quantification of the disorder in the data set, then I would personally go for the entropy unless, again, you have a very good option for the variation ratio, a very specific reason that you want to go for it.